Chapter 4 is about the building codes, and one of the things you got to keep looking at in Chapter 4 is all the different histories that go on with building codes and the basis of the building codes, and explains the difference between the fire and the building codes. There is a difference, and the construction codes and how they all have an impact on the fire service. Objectives are pretty much the same. The fire protection systems and building and fire codes are all about basically saving lives and living in an environment. The building codes history goes back to the late 1800s. The National Association of Fire Engineers and aid protection concerns were all came apart. But the biggest thing was the insurance agency realized one thing, that they need to have a code that makes sense. So the model codes were developed, and so came about the National Building Code, the Unified Building Code, the Standard Building Code, and of course out of all that came the International Code Council, which today exists. Older codes were regionally adopted, but no longer are, are no longer produced. Fire codes today generally have an update every 3 years, and they all are based on the standards. And if you know about the standards, it comes out of NFPA and the various testing agencies that support those standards. Fire code regulations is for to be employed on the fire service after the building is built. Basically, I tell everybody, we never get a divorce from a building. We inherit it till the day it goes on the ground. And I think the biggest thing I can tell everybody is that if a building is built bad from the beginning, the fire department always has to deal with the inspection headaches that go with that building. And again, the fire codes and standards are updated every 3 years. Testing standards is the American Society of Testing of Materials. ASTM E119 is the testing method for all construction materials, but it does change by standard of testing. ESTM E84 is the fire surface or the surface burning characteristic, and that's also used to determine what type of building materials are out there. Construction codes have come into the International Building Code, NFPA 5000, and of course the hybrid buildings that are out there. This kind of gives you an example of the codes and the references, and I direct you to the text on that. Occupying and classifications of building codes and how are they employed by the occupancy and the type of building that's being built. You got to remember A1 through A4, B and E, B being educational, B business, F1 and F2, and then H1 and H5 being high hazards. But the biggest thing is A is for assembly, B is for business, D is for daycares or detention on a correctional occupancy, and E is for education. 5,000 types are healthcare agencies, high hazard components, industrial occupancy, mercantile, residential, and storage. Building height and size are required under various codes, and also local zoning controls the height of the building. So don't forget that. Modifications in the tables that are there. One of the things that's changed in the building code that I can tell you right now is we're now building high-rise buildings again, more than 4 stories. Most you'll start seeing 6 and 8 story buildings being built out of wood construction. The table 4.3 kind of lends you to how the construction type is, 1, 2, 3, 4, and 5, and the hour rating as needed. One of the biggest things is special hazards. You have special structures such as atriums. You got your high-rise structures. You got your open mall spaces. You got egress issues with all these buildings. What's a good way for the flow pattern, out of the building? But more than anything else, you have to look at the occupancies, how they're rated in the building, and the type of load that occupancy can handle. This slide shows you a set of double doors. That means that's rated for basically a larger occupancy to exit through. And you'll see this like in schools or theaters or even a nursing home, all in regards to how that works. So you see it also in hotels, and you also see it in, I would say, extended stays. Fire protection systems, a lot of them are regulated by the code, but the other problem you got is how people secure buildings. This is a good example. Look at the lintel and the crown arch on that building, but also look at the grate that's put over the top for vandalism and security break-ins. Areas of rescue and assistance are there, but the biggest thing you got to look at with all this is what is the purpose of the building and how are people going to get out. Again, fire protection systems, the way that goes. Elevators are key. Is it a hydraulic elevator or is it electric cable? All depends on the height of the building and the purpose of that elevator. You're not going to use a cable elevator on a 4-story building. You're going to use a piston type. But you're going to use a cable elevator on a 6 or 7 or 8, 10-story building. Phase 1 operations for recall. Phase 2 is for the fire department. They have access and to the upper floors. Elevators, post 9/11 changes, occupant elevators, evacuation elevators for limited signs, protection against water penetration, two-way communications, and recall from a fire command center were all changes that happened after 9/11. 9/11 also brought away eliminated horseways, minimum 150 square foot lobby, and class 1 hose outlets in the stairwells. Elevators door restrictions. You need to know how to open each type of restrictor found in your area, metal bars, and elevator keys. The building code itself provides a lot of good information. I direct you to read that. And code implications. What happens when the code doesn't address your concerns? You have to go through research, and what you do with that is just assess the proper code to the NFPA findings and how that comes out through code, fire code regulations, and also through the standards. The standards sometimes dictates how the code has to be applied. So in chapter 4, you're looking at what are the subsequent regulations and what's going on and how they've been in towns and cities and that. So this is a good example, quite frankly, of a quick summary of what you're going to see in this chapter. You need to read the chapter and understand what you're doing here. Thank you. Okay, we're going to start out with chapter 5 here, fire behavior and building construction. It's pretty much an add-on to what we dealt with the chapter 4, but you're going to start looking at some things a little different. The objectives here are the fundamental behavior and the key to fire phenomenon. The big thing is here, list the ways of building are affected by fires and the specific materials that behave under attack of fires. So we go into basically the fire behavior elements here. I'm not going to get into a long lecture on this. Basically, this is in your book. But the heat transfer is really important. This is a good example of conduction, convection, and radiation. Compartment fires basically is the incipient free burning phase, flashover, and smoldering decay. So those are key elements that you're going to see in the basic concepts of fire behavior. One of the big things you got to look at is a fire plume, smoke, heat, gases, ceiling layer, and the neutral plane. So when we look at these things, here's a good example of a working fire in an apartment building. As you can see how the fire is basically channeling itself up alongside the building. It's looking for fuel. It's looking for more oxygen so it can get bigger and bigger. This is a good example how wind sometimes can drive that fire upward and into another compartment space. But the big thing is, more than anything else, you must consider all the tactics that go along with fighting fires in compartments type fires. Got to look at the interior combustibles, the vertical openings, the height of the room, proximity of walls with each other, HVAC systems. A backdraft. What can cause a backdraft? I think you all know a backdraft right now is where all the gases in the building burn up and all of a sudden you introduce oxygen and boom, you have an explosion. A lot of times they call that a smoke explosion, but that's not really what it is. Your behavior is flashover. You don't want to be caught in one of those because if you do, you probably won't survive it. You have a backdraft, concealed fires, and rapid spread of fire. Today's fire service, I will tell you this right now, in lightweight construction, It doesn't matter if it's steel, if it doesn't matter in wood, anything lightweight construction. The rapid spread of fire in a building like that leads to one thing, a rapid collapse. And you have got to be very careful. You've got to understand that those components are combustible enough that they can turn around and deteriorate right in front of you. And as an entry crew and a firefighter, you could have a very dangerous situation. This kind of gives you an idea what happens when fire growth and spread. This is the aftermath that you'll see. This is a picture that is basically what happened after a fire there. In your book, you'll have the MGM fire. You'll also have the famous Coconut Grove fire, how fast that fire grew and lost of life going along with it, along with Beverly Hills in 1977. You got fire hazards, and the list goes on. And as you go through this, you look at your finishes, and you're looking at more than anything else why some of this comes back. Years ago, the big tents were put up, fabric, cork, rattan, and wood, and then they have a fire breakout, and people are dying because it collapses very quickly. Plastic is now one of our biggest problems. If you're looking at hydrogen cyanide, they just generated from plastics. It's thick, it lays in the air, but you also have SO4 and other sulfides that come about and an incomplete combustion. Look at the woods that you see today or the cosmetic furniture that you can buy. I hate to say it, at places like IKEA or any furniture store, there's a lot of plastic and polycarbonates involved. Here's a good example of a Cold War storage fire that killed firefighters in Worcester, Massachusetts in 1999. This was caused by vagrants in the building. It was an empty building, but yet we lost 6 firefighters. In the case studies that I present to you in this whole array of building construction is always centered around a line of duty death. And the reason why is because mistakes are made. I'm not here to point the finger. I'm not here to say this was right or wrong, but I'm pointing the finger at the building. So when you start reporting on this, start thinking about the building and what happened with the materials. And you'll be surprised how sometimes we just walk away and don't even look at what we just walked into or walked out of. And we get blinders on. Today's office buildings, you got a lot of cubicles going on. So the big thing is now you got additional hazards with decorations, Christmas tree, people making haunted houses, glass reinforced plastic in the houses and that. But today's fire load and the heat of release is greater today than when the fire codes were basically put into a written form. First International Bank fire, hotel remodeling, regulations in California, Boston, and the Port Authority of New York and New Jersey all have different takes on what they want to see in their fire protection. Control of rapid growth is important, but the biggest thing and more than anything is know your products of combustion. Smoke tells you a lot. Airborne and liquid particulates produced by fire, hydrogen cyanide, carbon dioxide, CO poisoning. More damage is with property. It can be done with, excuse me, more property damage can be done with water than with fire. CO is a flammable gas taken to the right ignition temperature. A combustible leads to flashover and backdraft. Accumulated gases in the closed area of ventilation do not prevent CO explosions. You got to look at this. You got to ventilate a structure the proper way. You also got to look at what's burning, and you also look at how these gases are going to build up on you and how quick they can turn the tide in a structural fire. You got to look at the physical effects on people. CO is odorless and tasteless, and smoke particles can prevent air from filtering through properly, causing people to lose their sense of direction, and so on and so forth. Smoke damage may be the most expensive byproduct of fire. It's everything. It's basically you have a smoky fire, everything's basically destroyed. Contamination by radioactive material, polycarbonate, Biethylene is PCBs are very dangerous and are very costly to clean up. A nuclear plant in Hartford, Washington, the cleanup costs more probably than the plant itself, all because of the toxic effects of PCBs. Summary: fire behavior is critical for all firefighters. And the biggest thing is that you have to look at the associated risk with fire growth, how high flames spread the materials. Biggest thing is, more than anything else, look at the strategic events of a fire, how the fire has grown and where it's going and what's going to happen. This is chapter 5. Chapter 6 is a very long PowerPoint slide presentation, and I'm not going to go through the whole thing. Non-combustible buildings is part of it. Fire terminology is part of this. Non-combustible buildings, again, fire resistant designation, early fire test. This gets into the testing of the products of combustion and how it is. There's some history involved in this. You start to understand what the fire endurance is. I did put a thing out there for fire endurance for you all to look at. Hannity's fire rules of fire endurance is important. And the big thing is, more than anything else, to start looking at how those principles are still applied today. Some of these things came back a long time ago, and quite frankly, they're still used today. Columns, floors, walls, beams, fire resistance is not, life safety, smoke control, dollar loss, everything is important. There's a good slide in page slide 18 in the book in regards to fire resistant testing and how things are done, and it gives you a good example where that goes through. The big thing is, as I go through this chapter very quickly with you all, is the fact that this is just a snippet of what you have in this chapter. And you have to look at fire containment systems that are being installed, fire dampers. Buildings have fire dampers in it. There's a massive amount that goes into the ductwork in regards to the HVAC, so it can stop the flame spread of fire through a duct system. Fire doors have to be rated, and they need to be in any commercial structure. Generally, you'll see fire rating doors at 2 to 3 hours. Good example of that is a swing door like this with panic hardware on it. Big thing is overhead doors and rolling doors. These are all part of this, and so is the closure on the building. So you got all these to deal with. Problems with closures, what happens is generally in a real smoky environment, they become stick. They stick and hard to open up. And sometimes the people block opening and self-closing doors. And the problem with that is the fact when they block it, it makes it very difficult for the door to react the right way, what it's designed to do. The other thing is stairwells. People like the little wedge things in stairwells and put stuff underneath the steps in that. Case in point, it's all part of a system that can't endure storage underneath of it. It's designed to stay open so that it's free of any type of fire threat. You have smoke barriers in buildings. Excuse me, smoke barriers in buildings, and most buildings today are now smoke-free and under the laws. So we have all that. Escalators are important. You got to understand what they do, and you do the compartmentalization. The book published in 1930 was called Fire: The Design for Automatic Vents and Trip by Fusible Links. Big thing is the Holland Tunnel. There's some interesting comments about the maximum amount of CO to be generated by an automobile and what was the acceptable level because of pressurization. And here's a good example of what happened in a Holland Tunnel. It required an airflow of 50 miles an hour, a triple tunnel arrangement, and they had a fire and basically closed the tunnel, and it had to be redesigned. The Eurotunnel is an extensive design. You have to look that up. Automatic sprinkler systems and the type of sprinkler systems that are out there, and the pros and cons. Misconceptions about sprinkler systems is they cause Sprinklers cause damage to libraries. Smoke detectors set off the sprinkler system. No. Smoke detectors do not set off the sprinkler system. Fire sets off the sprinkler systems. Big thing about all this is when you look at these misconceptions that are out there, you start to understand that the sprinkler system is the most proven water suppression device that we have out there. Once used the proper way and in protection of an area, water damage can work. And now we have high pressure water systems, and we also have water mist systems. These are even proving out to be better than we've ever expected. Keep this in the back of your mind. Department policies are important. Company levels of inspections are important. How people have got to look at construction, high-rise building, preservation of historic buildings, and unsprinkled voids. Sprinkler fraud. There are a lot of people in today's world that want to think they're a sprinkler contractor and they shouldn't even touch a sprinkler pipe or a sprinkler head. Management and management is managing the fire department rather than managing the fire problem. Have a sprinkler protocols in your SOGs. In other words, go look and see what the fire department has developed or needs to develop as far as sprinkler management systems on high-rise buildings and so on and so forth. A lot to go through here in regards to they call it ESFR systems. That's early suppressed fire response systems. Okay. You also have standpipe systems, standpipe water, NFPA 72. You also have the codes from NFPA 72 initial devices, panels, pre-plans, the type of communications device you're going to see. Most of what we have now is an addressable system that tells you where the smoke head number 202, and you should have a chart right there that tells you where 202 is to go find it. Public address systems in that, smoke management systems, they're very important today where you have smoke management systems that have not only smoke control, purge the area, but it has a zone smoke control, designated airflow design with it, and it also gives testing criteria, how you do it. Control panels, pre-planning fire considerations, all these are important to you. And this is a very brief overview, this chapter that you have. I hope you enjoyed it, and if you have any questions, by all means, call me.